students?
Yes, sir.
Rameshwar
Arun.
and Tarun. Today which chapter we have decided? We have decided to start magnetic effect of electric current because you are having examination. Okay, right. So we will be starting today magnetic effect of electric current. Okay. So now you see that here the word magnetic. One word is there that is called magnetic. Okay. Magnetic is a separate process, separate phenomena which is taking place in nature. Okay. Similarly, electric current, it is also a separate physical phenomena. Magnetism is a separate phenomena. Electric current is a separate phenomena. We have already studied electricity chapter.
Yes, sir.
Correct? Okay. So that previous chapter, electricity, already we have finished. And in that electricity, we studied about current. Did we study about current?
Yes, sir.
So we studied about current. What was current there?
The electrons are flowing.
Okay. Right. So what you can say, current is rate of flow, okay, of electrons. Or in words, one word you can say that it is charge. Charge.
Sir, that light.
Okay. Here you see. I think it will be visible.
Yes, sir.
Rate of flow of electrons. Rate of flow of electrons or charge. Okay. Or charge is called current. Correct?
Yes, sir.
Right. So what it was? I is equal to Q by T. I is equal to Q by T. And I is what? Electric current. Where I is equal to electric current. Right. And T is time. Q
Charge.
is charge. In this case, what you can say? Electrons. Okay. If suppose this is chemical current, then there will be ions.
Yes, sir.
There will be ions. Here, in metals, in conductors, electrons are the charge carriers. Okay. So rate of flow of electrons or charge is called current. So we are talking about metallic current now, not electrolytic current. Okay. What we are talking about? We are talking about metallic current. Metallic current, correct?
Yes, sir.
Metallic current means what? Current in a metal. And a metal consists of infinite number of free electrons. Okay, metal consists of
Infinite number of
many number of free electrons. That free electrons only when it is moving, then only it will constitute current. Correct? Okay. So that is metallic current. And when it will be electrolytic current? Electrolytic current. So in this charge carriers were electrons. And in this charge carriers are ions. Ions. Correct?
Yes, sir.
Okay, you have understood this?
Yes, sir.
Right. So that electric current already, this one already you have written. Already you have written for electricity. Correct? When we discussed about electricity, you have already written. Just for your reference purpose, for your knowledge, we have revised this particular part. Correct? Okay. So that electric current, already we are knowing that what actually is an electric current. Then magnetic effect of electric current. So before that, we need to discuss about magnet. Magnet and magnetism. Okay? Magnet and magnetism.
Yes, sir.
Right. So what is a magnet? What is a magnet?
This is one phenomena.
Yes, how can you define a magnet?
Sir, it has a positive or negative charge, sir.
North pole and south pole.
Positive or negative poles.
Poles, as a poles.
Positive or negative poles like this in magnet, it is not there. There is no positive and negative pole.
North pole.
Charge may be positive or negative, correct? But poles are not positive and negative.
And south.
Yes, good.
South pole and north pole.
South pole and north pole. Okay, so a magnet consists of two poles, that is south pole and north pole. Very good. Okay, so magnet is actually when you are going to define a magnet. So magnet is a substance. Magnet is a substance which is having some attractive property.
Property, yes.
Okay, which is having some attractive property or which can create a force. Which can create a force. So you can say a magnet is a substance. Okay, presence of which creates a force on another body. Okay, on another body. So a magnet is a substance presence of which creates a force on another body. Okay, so this is the definition of a magnet. Similarly, now this magnet already we have defined substance presence of which creates a force on another body. Now this force may be attractive or repulsive. May be attractive or repulsive. So as we have discussed in electricity, so like charges repel each other. Okay, like charges repel each other, unlike charges attract each other. Good. So in electricity, so we can say that in electricity, like charges repel each other. Whereas unlike charges attract, correct?
Yes, sir.
So there positive charge and negative charge will attract each other. Whereas positive, negative will be repelling each other. Okay. So in that same manner in magnetism, when like poles are coming near to each other, when like poles are there, so it will repel each other. When unlike poles are there, then it will attract. Okay. Right. So this first point already you have noted down?
Yes, sir.
First point, second point?
This is going to
Okay. Can I rub this first point?
Yes, sir.
Okay. So similar to that, what we can say regarding magnetism, that in magnetism, in the case of a magnet, what we will be writing? In the
case of the
a magnet, which is similar to charges, charges in electricity. So what happens? Like poles. Okay, so like poles repel each other, correct?
Yes, sir.
As you are already knowing that a magnet consists of two poles, correct? So like poles repel each other and unlike poles attract each other. Okay. Here you can write that a magnet consists of two poles. A magnet consists of two
Poles.
poles. One is
North pole.
north pole
South.
and another
South.
is south pole. You know that Earth is also a magnet.
Yes, sir.
Yes, sir.
Earth is also a magnet. Then only all the bodies are getting attracted towards the center of the Earth.
Yes, sir.
Okay, so Earth is a big magnet. Earth is a big magnet. Correct?
Yes, sir.
Due to which it is having a strong magnetism, due to which all the body is attracted towards the center of the Earth.
Yes, sir.
Correct?
Yes, sir.
Okay. Right. So the main thing, the magnet consists of two poles, north pole and south pole, and in the case of magnet, similar to charges. Here also like poles repel each other and unlike poles attract each other. So if you are going to draw a magnet, this type of magnet,
Bar magnet.
which is just like a cuboid shape, it is called bar magnet. Okay, so it will be having one north pole and another one will be having a south pole. This is called actually bar magnet. You can write here bar magnet. So we can have different shapes of magnet also.
Yes.
Okay, so one shape will be there like this. What is this magnet called?
Horseshoe magnet.
Horseshoe magnet. Okay,
Horseshoe.
so horseshoe.
Yes, sir.
So this one will be north and this one will be south. So this will be called as horseshoe, right?
Yes, sir.
Magnet,
Horseshoe.
right? Now, if you cut these magnets into pieces,
How?
okay, so can we separate south pole and north pole?
Yes, no, sir.
No,
No, sir.
we cannot separate.
No, sir.
Okay, why we cannot separate?
When we cut it in two parts, sir, in another end, no, sir. It also consists south pole, sir.
Okay, right. So another pole will be generated there. So in you can say in whatever pieces you are cutting it, each and every piece will have
North pole and south pole. sir.
north pole and south pole. Each and every piece will have north pole and south pole. Okay? Can I rub this point?
Yes, sir.
Okay.
Yeah. So you can drop fully, sir.
Right, very good. So let the bar magnet be there. So you can say if we cut the magnet into pieces, correct?
Yes, sir.
Each piece will have two poles, one north pole and one south pole. So in this way, what you can say that poles cannot be separated.
Yes, sir.
Poles cannot be separated. Okay, so simply only south pole, only north pole, that type of magnet we cannot get.
Yes,
Yes,
sir.
sir.
Right? Okay. Right. So this was about magnet. So what we can say now, magnetism. So what actually is magnetism? So magnetism is the property, you can say, by which the force of attraction or repulsion is created on any other object. Okay, so magnetism is the property of a material by which the force of attraction or repulsion is created. on another object. Right? So magnetism is a property of the material due to which you are creating a force of attraction or repulsion. Right. So now we will be discussing about types of magnets.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Finished? Okay.
I am sir.
Right. So when we say types of magnets, see some of the magnets which are available in nature itself. Okay, as we have already discussed that Earth is a big magnet.
Yes, sir.
Okay, so that nature only has given that magnet.
Yes.
We human beings have not created
Yes, sir.
that type of magnetism in Earth.
Yes.
Correct. So you can say that some of the magnets which are found in nature itself, and those type of magnets are called natural magnets. What?
Natural magnets.
Natural magnets.
Magnets.
Okay, which are found in nature of its own. So you can say one example, that is magnetite, which is an ore of an iron,
Yes, sir.
which is
Ore
an
of an iron.
ore of iron. So it is behaving like a magnet only, and it is found in nature. Similarly, second one, artificial magnet. Correct? So artificial means what?
Which is made by human being.
Yes, which is made by human being. Okay, so which we create in laboratory.
Yes, sir.
Huh?
Yes, sir.
Okay, so you can say magnets created in laboratories are called artificial magnet. In example, you can say electromagnet, right?
Yes, sir.
Even magnetite, this is also called as lodestone. Lodestone or magnetite. Huh? Okay, right. So understood now
Yes,
what
sir.
is magnet
Yes, sir.
and what is magnetism?
Yes, sir.
Magnetism is the property by which the substance creates a force of attraction or repulsion on any other object. Okay. Electric current also we have studied. Now we will be discussing magnetic field. What we will be discussing?
Magnetic field.
Magnetic field. See, what happens, suppose you are having a bar magnet, right?
Yes,
It is
sir.
having a north pole and south pole. Okay?
Yes, sir.
Now this bar magnet,
Yes, sir.
what it is there, suppose you are bringing any other magnet.
Yes, sir.
Any other magnet, suppose you are bringing, and suppose one magnet you have brought. So suppose any pole, south pole or north pole. See, from infinite distance, it will not be experiencing any force.
Yes, sir.
Okay, from infinite distance, this magnet, suppose this magnet is fixed.
Yes, sir.
This magnet you are bringing. Okay, so from here if you are bringing from far away, so this magnet will not experience a force.
Yes, sir.
When this magnet will come to a certain distance, okay, within this region, the region
Field, sir.
of this magnet, okay, certain distance it will be covering, and near to this magnet when it will come, it will experience a force. Okay, so if it is south pole, it will be experiencing a force towards north pole.
Yes, sir.
Before that, at particular point, these places, it has not experienced any force. But when it has come to this particular point, it has experienced a force. It means the effect of this magnet is in this region. Correct or not?
Yes, sir.
This effect of magnet has started.
Yes, sir.
Earlier, that effect of magnet has not started. So it was not experiencing any force of attraction or repulsion.
Yes, sir.
But when it is coming to a certain distance from this magnet, it will experience a force. If it is south pole, it will be attracted towards north pole. If it is north pole, then it will get a repulsive force.
Yes, sir.
So that region created by a magnet surrounding to it, in which force can be experienced, is called magnetic field. So you can say that surrounding to this magnet, up till like this type of one region is created.
Yes, sir. Field.
This magnet when it is placed, it will be creating a region
Yes, sir.
where some effect will be taking place on another object.
Object. Yes, sir.
Outside that region, there will not be any force of attraction or repulsion on any other object.
Yes, sir.
Understood now?
Yes, sir.
So magnetic field is a region, a specified region. Okay? So we will be defining now a magnetic field. So we can define a magnetic field. So the region surrounding a magnet in which a force of attraction or repulsion is created to another body when it is brought in the vicinity of that region. Vicinity means near.
Nearby.
Okay, near, in the vicinity of that region is called magnetic field. Understood?
Yes, sir.
It is called magnetic field. Can I rub this one? Types of
Sir.
magnet?
Yes, sir.
Okay. Okay, so we can carry out an activity. We can carry out an activity. So what activity is? Suppose you take a piece of paper. Okay.
Yes, sir.
If you are taking a piece of paper and you are putting there some iron fillings, right?
Yes, sir.
These iron fillings are in scattered form. Okay, anywhere it is.
Yes, sir.
Iron fillings means small particles of iron.
Yes, sir.
Okay, so that is small particles of iron you have placed in this paper.
Yes, sir.
Now you bring one bar magnet, and that bar magnet you just take it to the bottom side of this paper.
Okay, sir.
Okay, bottom side of this paper, and you just move this iron bar, this bar magnet at the bottom, you move that.
Yes.
Okay, so due to its presence, what you will find, these iron particles will
Combine.
arrange themselves in a particular fashion.
Yes, sir.
Okay, so earlier it was randomly placed.
Yes, sir.
Earlier it was, you can say, scattered.
Yes, sir.
These particles were in scattered condition, randomly placed anywhere. But now when this magnet has come here, so the effect of magnet has created these particles to get arranged in a particular fashion. Okay, so you can see that these particles will be arranging themselves like this. Okay. What it is showing? It is showing that one pole is here,
Yes, sir.
north pole, another pole is south pole here. Okay, so what you are finding here, so see, near to the pole, more congested or you can say more density of iron filings will be there.
Yes, sir.
Okay, near to the poles, so you can say that like this, it will be correct. So near to the poles, more density of these lines or you can say these particles will be there in comparison to these poles. In comparison to these poles. Means in between the poles more density will not be there. Hardly one or two scattered particles will be there. So all the iron particles will get arranged near to the poles. Okay? Right. So by this activity we can find out that it is creating some type of field. Some type of field it is creating, magnet. Right. So now we will be discussing magnetic lines of force. Magnetic
Lines of force.
lines of force. So magnetic lines of force actually you can say that similar to magnetic field. Okay. So in that field, how that lines are created. So what it is, suppose this is a bar magnet. Can I rub this on magnetic field?
Yes, sir.
Okay. Right. So now I will make it another one. This is a bar magnet consisting of north and south pole. Right. So magnetic lines of force actually from here also we can draw in paper. So what we are finding, magnetic lines of force is moving from north pole, okay, and entering in south pole. So magnetic lines of force like this, right? It will be in this way. It is entering to south pole, and inside the magnet, that magnetic lines of force are moving from south pole to north pole. Inside the magnet, outside the magnet, from north to south. Similarly here, correct?
Yes, sir.
Like this. So it will be forming a circular pattern. It will be forming a circular or you can say a spherical pattern. Okay, on that pattern is like this, and inside from south to north. So you can say these magnetic lines of force. So outside the magnet, what? From north pole to south pole, and inside the magnet from south pole to north pole. Okay. Now what you find, what you find here, these magnetic lines of force are very much dense near to the pole. Dense means it is very close to each other. See, one more thing, in electrical lines of